DCW Asia 2025 Singapore. I'm pleased to be joined by Mark Roberts from Castrol. Thanks for coming along, or me coming along to see you,
No
rather.
problem at all.
Excellent. So my first question to you is, where do Castrol fit into the data center ecosystem?
That's absolutely a fantastic question because we get it asked so much. So of course, as we've moved into liquid cooling, the actual fluids themselves are critical. So we initially started off with immersion, obviously being a big oil company, but we recognise that the industry is very much going down into the direct chip market at the moment. So we pivoted in December last year. We've been first of all getting the PG25 fluids into market, getting approvals with hyperscalers and OEM vendors in terms of the service side. And more recently, we've started bringing in our end-to-end services. So when we talk about end-to-end, we support the installation and commissioning side. We also look at any preventative maintenance, if there's a break fix element as well, and also disposal. Fluids actually used a lot in DTC for flushing. So there's a lot of fluid that we then need to get rid of, and you can't just put it down into a drain or anything like that. So we work with our current fluid ecosystem to be able to actually put that into an ethical and environmental recycling of the fluid itself.
Awesome. Well, that was in a nutshell. Thank you. So how many things are you showcasing today?
Yeah,
or yesterday as well?
Yeah. So what we've actually done, we mentioned the actual PG25 fluid itself, spoke about the end-to-end services, and now we've moved to the next stage, which is the actual introduction of complementary products to the fluid. And as DLC has started to get implemented, we've recognised a number of challenges that the operators have that we're trying to solve for them. So the first product we've got kind of fits into the installation and commissioning, but also in maintenance. So moving around a lot of fluid in a big 1,000-litre tub with a pallet jack or in a drum, it's not really great in white space of a data centre. So we've found a way with the liquid refill cart to be able to actually do that safely and to actually decant outside of the space, move the fluid in, and then we actually decant it either into a rack manifold, or alternatively we put it directly into the secondary fluid network. So the idea is that we don't want the fluid levels to be too low. Otherwise, we'd actually start introducing air, which is obviously not great. So we've got level sensors to protect it on that side. And then we've also got sensors in here on the actual nozzle when we're feeding into the unit that will actually enable us to, if we're putting too much pressure into the system, it will cut off and shut off. It means we can't damage the system. It also means that we can't spill out of the system either. So we've got a number of protective measures within that.
So it's got fail-safes.
Yeah, absolutely, yeah.
That's fantastic. Shall we move on to the next thing?
Yeah.
Okay, Mark, what's this now?
So we've been designing data centers for many, many years now, and we've done everything to design out single points of failure. And with liquid cooling, we've just introduced one, i.e. the fluid itself. So there are ways that we can sample on site with handheld tools, but that also brings an element of risk. It also, periodically, you can't be doing it all the time, and then you can also send to labs as well. So we offer all of those services, but we also recognise that in the current data centres where we're actually measuring air and we're looking at temperature and humidity, we're doing that dynamically. We're doing it every few seconds. So we're taking that concept into an actual analyzer for the PG25. So making sure that the health of the fluid is good. So in terms of the actual variables and parameters that we're monitoring, first of all, we're looking at the glycol concentration, we're looking at conductivity, we're looking at pH, and we're looking at turbidity. The reason we've chosen those is because the OCP guidelines are recommending them, and in order to actually get a low risk profile for your DLC circuit, you should be installing an analyzer. In terms of the way it actually works, the unit sits on the return circuit on a bypass. It takes the fluid into the unit, it goes over the 4 sensors, it takes 10 readings, and that aggregates and then displays it of what then happens. And that repeats every 10 minutes. We can do it more frequently, but it probably doesn't make sense to do so.
Right, Mark, you brought me round to the front of which looks like a substantial bit of kit. Can you talk me through it?
Yeah, absolutely. So the actual unit that you're looking at is a liquid load bank, and this fits into the commissioning phase of the end-to-end services. The actual front of the rack is where we bring in the power, and it can either be a 63 amp three-phase connection, or we power these individual sockets through a three-phase PDU. On here, we also have a HMI, and that HMI is going to display the temperature in and out. It's going to display the pressure on the front side and the back side. It's got a leak detection with an alarm, and it's also got the flow rate as well. In terms of bringing power on, it scales from 1 kilowatt all the way to 180 kilowatts. This is actually designed to emulate a full GB200 rack or a full GB300 rack. So we can actually test the full secondary fluid network in a safe manner without putting any of those expensive servers at risk. So we get the load, we bring the load on, we drop the load, and then once we've finished all the commissioning, our USB is taken out and it presents all the reports as part of the commissioning procedure.
Okay, Mark, so what's going on here now?
So at the rear of the rack, this is more of the water infrastructure. So first thing to point out is the manifolds on the side of the rack. We can actually feed into the manifold from the top or from the bottom. Obviously, we've got the blue is the supply of the fluid in. That will go into each of the load banks and then get heated up by the resistors in there. And then it will exit via the actual hot and then exit the rack itself through the return manifold. There's not too much else at the back apart from a pressure valve, and that's very important because that can actually set the pressure that we should be seeing at an individual server level, and it can also help us to create fault scenarios. In that way, we can actually test if we set the pressure too high, what happens in terms of warnings and alarms in the BMS, and to make sure that everything in that secondary fluid network is working as it should.
Mark, that's absolutely awesome. Thanks for walking me through this. I know you're a very, very busy man because I've been trying to get hold of you for 2 days. But thank you for taking the time to speak to me. Really appreciate it. Enjoy the rest of the show and have a safe journey home.
Thank you.
Thank you.